In this video, we will talk about simple machines. Our topic of concern is simple machines. And if you look to our day to day life, if you look around yourself also, if you look at everything that works around you, everything works on the basis of simple machines. I mean, the idea itself is around the simple machines, and then you make it more complex and complex and complex. And that is why the term itself is like that, because you will have a simple machine, you have a complex machines. So why the use of machine is there actually? So there are a lot of things that requires a lot of human efforts, so that have efforts can be reduced. How we can reduce? Simply the human work can be done by the simple machines as well. Like a person can simply lift an object, but the pulley will makes it easier. A person can also what you can say, move an object somewhere else as well, but the inclined plane can help the object to go up and down easily. So like that, there are a lot of different ways through which you can actually see and utilize these machines, and that too simple machines. Now if I need to define the simple machine, what I will say is a simple machine is a tool that helps us in doing our work more easily and efficiently. See, we human can also do the same work, but it will take a lot of effort, a lot of time, and it should not be efficient also every time. But machine can do that easily and efficiently. It has no energy of its own, first of all, because it is artificial. And that too, we are putting our efforts there as well so that it can work. So it has no energy of its own. So it cannot do work by itself. We have to give the instructions, we have to give the input so that it can give the output, just like a computer that you are using. So when we perform work on a machine, then the machine will in turn perform work on some other project or other object also. It could be a project also, depends on what you want to do, and it could be on the object also. Let's say if you want to move an object. So it's a very simple idea. You want to do something, there is a machine there, you will utilize that machine and your work is done. So that is how you can simply define it. In other words, what you can say is a machine can do work only when the work is done on it. So this is the idea here, because the machine is something which is, as I said, is artificial, doesn't have consciousness. We have the consciousness. So we will only do work when we want. But machines are not like that. When we do the work on them, or as I said, when we give the input to them, they will give the output into us also or to some other object also. So what are the conditions of an ideal machine? Or like if I say for an ideal machine, a perfect machine, work done by the machine is exactly equal to the work done on the machine. That means what I'm trying to say here is that whatever the input you are giving, it should be equal to the output. So let's say if I talk about in terms of value, if I put 10 joules of energy, I will get 10 joules of energy back. So this is a perfect ideal machine, which we always try to achieve, but somewhere here and there you will always lose some sort of energy. So something like that will always be there. But this is like the perfect condition. Now, the important applications of a simple machines, like what are they? So first and the most important is it will multiplies the force. So usually when the objects are heavier, when the objects are bigger, then they are difficult to move. So in such cases, simple machines are pretty much useful. The second is machine helps to change the direction of the force. Another important feature, because again, if it is very heavy, it is very difficult to move and it is very difficult to change the direction as well. So then it is a perfect thing. A simple machine can be a perfect thing to utilize that. Third, a machine can change the speed as well. Obviously, if you multiplying the force, it will obviously increase or decrease the speed as well. A machine makes the force to act at some desired point. So there are certain places, like let's say, let's take an example of a screw or a wedge where you want the force on a very particular point. So that also you can do with a machine. Where if you do that with your hands, particularly, that will require some effort and that will require some efficiency to do that at a very accurate point. And fifth point is a machine enables us to do dangerous and unsafe work also. I mean, again, if you are thinking that you can take a piece of wood and use it like a screw, that would be a very dangerous thing. You can lift up any heavier object by yourself, you might have dropped it and it can hurt you as well. So it is like helping you to do the dangerous and the unsafe work. And a machine does not perform all of these functions at the same time also. It may do one or more of such functions at a time. It is not multitasking like us. I mean, we can make machines like that, but if I talk about simple machines, they are not like that. They do one task at a time. So this is about the simple idea of simple machines. Now there are a lot of terms that revolve around the simple machines. We will talk about those. So there is a very important term, that is effort, means the force that we are applying to the machine. As I said previously, the input is equals to the output. So whenever you say about the input, you are using the term effort. Whenever you say about the output, you will use the term load. It is the force exerted by the machine on an object on which the work is to be done. So basically there is an object. So we are, let's say there is a screw or a nail. So you are hitting the nail. So we are hitting the nail with a hammer. So we are putting the effort. That's called force. That is the input. Okay. And you are, the nail is going inside the wood, let's say. So that is the work done by the nail to go inside the wood. So that is a load which is done by the nail. Okay. So like that it will work. Then the other important thing is a fulcrum, which is very important when you talk about lever. Okay, so it is a fixed point about which the machine can turn while doing it. And all of that collectively comes together in this very important thing, because these effort, load, and fulcrum is a very important things when you calculate the mechanical advantage. It is measured by the ratio of the load to the effort. As I said, you should know how efficient your machine is or how much you're getting an advantage out of that machine. So you have to calculate it. And how you will calculate it? With this formula. Mechanical advantage is equals to load by effort. Okay, so we use this formula, we calculate the value, and we can tell whether it is advantageous for us or it is not. So since load and effort both are forces, so we measured in Newton because the unit of force is Newton. Hence, mechanical advantage is a pure number and has no units. Basically, you have load over effort. So it's like Newton over Newton, so you can cancel Newton and Newton, so there is no unit at all. And that is why the mechanical advantage doesn't have unit. Another important thing which we can see in the previous slide is like the different types of simple machines also. Like as I talk about the mechanical advantage, so the first type is the lever that you can see here. So you can see the presence of the fulcrum. So as the presence of the fulcrum is there, you can actually see the different type of a lever. Okay, then you have the inclined plane. So in our day-to-day life, if I talk about lever first, you can see there are multiple places you are using the lever. Even in our body, the joints and the bones works on the principle of lever. Okay, inclined plane, as you can see, moving a object to the higher, let's say you want to move some dresser, or let's say some almirah, which is very heavy. So the inclined plane can do the work very easily. Wheel and axle, we are using that in our bicycles, we are using that in a lot of places as well. Again, a very simple machine. A wedge, which I talked about in the nail, which is like acting a force on a very certain point. Pulley, pulling a heavier object. So inclined plane is pushing an object, not pulling completely. But pulley is like pulling an object to an extent where like inclined plane doesn't work at all. And then the screw. The difference between wedge and a screw is the screw will give you a lot more area and a lot more ability to do the same work which cannot be done by the wedge or the nail, I can say. We will discuss, I mean, this is something which can discuss particularly when you discuss and study the wedge and a screw, particularly what is the difference there. Okay. Now let us come to the input and output, as I told you. So input, as I said, which is work done on a machine, and it is nothing but the effort, the energy supplied to the machine. And output is, it is useful work done by the machine, which is load. The energy imparted by the machine means the work that you are getting out of the machine. And utilizing that, you can actually calculate the efficiency of a machine, which converts your input energy into useful output energy. Okay, and like you will lose some kind of energy there, it will always like that, you will lose to overcome the friction, there are moving parts as well. So no machine is an ideal machine, as I said, you will always lose something. But again, you will always try to understand how efficient is that machine, and in order to calculate that efficiency, you will use this formula called in output over input. Okay, and this output over input will always comes in a percentage. So again, in order to calculate the percentage, you always multiply it with 100 as well. So efficiency, you will, if you need a simple value, you will use this formula. in output over input. Since you need it in a percentage so that you know how efficient that is, you simply multiply it with 100 and you will get the value in a percentage as well. So efficiency of an ideal machine is 1, which is 100%. Okay, but the efficiency of a machine in actual practice is always less than a 1. It's just, again, as I said, there is no ideal machine. It will always, in some way or other, you will lose the energy, you will lose the efficiency. So this is how you can understand the whole functioning and understanding of a simple machine and what are the different terms and how you can calculate the efficiency. I hope this will be helpful to you. Thank you.